All right, so we're going to use Kirchhoff's law on this circuit. Why? Because it's icky. This is a specific kind of a circuit that appears on all sorts of awfulnesses. And again, the problem is you've got something, and these two look like they're in parallel, but this piece here is in parallel with these two in parallel. So you basically get this wing off here and the wing over here, and you get this resistor off to here. So it gets a little hard to figure out what it is you're supposed to be doing with this circuit. Again, you could do this one. This is not across the line. The ones that we're going to do after this one, you can't. You just cannot do them. So I'm going to start writing. I'm going to look at loops, and I'm going to go, what loops do I want to do? So the first loop I'm going to do is I'm going to do bad. Now, I'm just choosing. You could choose any one you want. You just have a lot of equations, a lot of unknowns. In this case, I'm going to say, okay, so what's my voltage? My potential difference has got to be 0 because I'm going to go from B to A to D and back to B, right? So I'm going to go, that's equal to. Now, I need to write down some arrows on this thing. So I'm going to write down some arrows so that I can keep track of what I'm doing. I'm going to call this one here I1. I'm going to call this one here I2. I'm going to call this one here I3. I'm going to call this one here I4. I'm going to call this one here I5. Now, these have to have directions. If you get the direction wrong, all that happens is you end up with a negative sign, and that's okay too. I5 is the same for both these. Why? Because there's no place a current can go through here and change, right? So looking at BAD, I'm going through these two, and they're both I5, so that's just one big 2 ohm resistor essentially. So I'd write that this is equal to I5 times R. That's my voltage drop. And it is a drop, so I'm going to put a minus sign on there, right? If my current's going this way, I'm losing potential as I go this way. Now, here's the tricky part. I4 I drew this way, right? Which means as I go this way, I'm going against the current, which means I'm going up the waterfall, right? I'm gaining potential, right? So this would end up being a plus I4. Oh, I just wrote down an R. The R is actually 2 for that. My apologies. Okay with that? Because I got 1 ohm resistor here, 1 ohm resistor here, so the resistance will be 2. I4, 2. Okay? Now, I'm going to simplify because I'm going to have like 5 equations, 5 unknowns, and if I simplify this carefully, I get 2 I5s equals 2 I4s, and that means that gives me that I5 is equal to I4, which is nice. Already I've got something that I might want to use. Okay? That's one equation, so I have 5 currents. I need some more equations. Okay? So what else might I choose to do? I might look around the loop and I might say, well, what if I do the top one, CBD? How about CBD? Would CBD give me something interesting? CBD. All right. So CBD, what would that give me? Well, it's going to give me another equation. I'm going to go ahead and write that one down. This is one equation, dot, 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 dot. I'm going to change colors so I can keep track of where I have a new equation. That's going to give me, so I'm starting at C, I'm going downhill, right? So I'm going to lose voltage, right? I'm going the direction the current's going in, at least the way I drew it. And that's I2 times 1, that's a negative, minus I4 times 2, plus, why am I, this is a plus? Because I drew the current arrow this way, expecting the current's going to go that way. And I get negative, no, not negative, positive, because I'm going up current, I3 times 2. That's my second equation. Okay? All right, so you got I3 times 2. That's going to be interesting. Okay, so what else could I do? Okay, I could note that I2 splits into 2 currents, right? Because not only do I want to do these voltage drop things, I also want to keep track of what the current's doing, because those are going to be nice, easy equations. So I2 has to be equal to I4 plus I5, because all the I2 goes to here, and some of it goes down I4, and some goes down I5, right? So I could do over here, let's pick a different color like red. I could do I2, times 1. No, not times 1. I'm just doing currents, right? So I2 equals I5 plus I4. That makes sense? So far, so good. Okay, so now I got 3 equations I wanted to play with. All right, So now let's give me another equation. What other equations do I want to do with? Well, up here at the top, I have I1, it's splitting into I2 and I3. Feels like that might be useful in the grand scheme of things, so I need a different color. So I'm going to go I1 splits into I2 plus I3. So again, what I'm doing is I'm looking at the top. Where's my pen? I can't find my pen. It's my pen. Okay, so I'm looking at the top. Still can't find it there. I2, I1. Oh, I just pressed the button. That's going to cause me carnage later. No, not too bad. Okay, so I1 becomes I2 and I3. So if I1 is, say, 5 amps, then some of it's got 3 amps might be going down I2 and 2 amps might be going down I3. That's not right because of ratios, but I'm not going to worry about that today. So far, so good. So I got 4 unknowns. So I got 4 equations, and I have 5 unknowns. Darn it, not quite there yet. I need another equation. What equation could I possibly do? Well, what else could I do? I could, I need to make another loop. Probably makes sense to include the battery. Let me see here. The battery's right here, right? I haven't done the battery at all. It feels like the battery might be useful for this process. And so I'm going to go C, D, around this loop like this, and back to C. Does that make sense? So here's my CD loop. I'm going to pick a different color for that one. Say purple. CD, and then around the loop, back to C. And so as I go around that loop, it's got to be 0 when I'm done. So I'm going to lose I3 times 5. I'm going to gain 12 volts. Wait, what? Okay, as that comes through now, I'm hitting the negative part of the battery and going to the positive side of the battery. So I'm gaining 12 volts. So I go up 12 volts, and then I come swinging around, and I'm back to losing stuff again. I'm going back downhill. So that's going to be I1, because that's how much current is going through this resistor, because it's what's going up there, and then times 5. That can't be right. It can't both be 5. Oh, this one's just 2. That's got a resistance of 2. With me so far? All right. Didn't mean to throw you there. Okay, so now I have 1, 2, 3, 4, 5 equations and 5 unknowns. I can solve this system. Has to be solvable, right? So if you're really good with matrices, now would be a good time to whip that out. I'm not going to do it with matrices because I'm an old man and we didn't have calculators that did inverses back in my day, so I don't know how to do that sort of thing. But I might notice, and see, I got this I5 equals I4. I could replace an I5 with an I4, couldn't I? So I could write I2 equals I4 plus I4, and I would note that that means that I2 is equal to 2 I4s, and that might be handy down the road. It's a second equation, so I'm writing everything in terms of I4, it looks like, and that's could be handy. And then I look here and I go, so what about here? Well, I've got I2 written in terms of I4. I've got I4 in terms of I4, obviously. So now I'm going to do the blue one, and the blue one becomes, I got to drizzle this out, I do apologize, that was badly written. So I got 0 equals, I2 is 2, so that's going to be negative 2 I4s minus 2 I4s plus 2 I3s. And so I might notice that 4 I4s must equal 2 I3s, and so I3 must equal 2 I4s. So yet I found yet another one that has to be written in terms of those sorts of things. I got I2 and I got I3 written in terms of I4. So now look what I can do here. I1 is now I2, which is 2 I4s, plus I3. I thought I had an I3. I don't have an I3. I do have I3. I3 is 2 I4s as well. 2 I4s. So now that I got that I1 has to be equal to 4 I4s. Okay, so I have current I1, I2, I3, and I5 all written in terms of I4. That's great, but I haven't yet solved anything. So I'm going down to my final equation, my final unknown. Again, there's a number of ways you know how to do final equation, final unknown, and not the worst thing would be using your matrix. After all, we did bother to teach that to you this year, or last year, I should say. So therefore, if you wanted to use that, that would be an awesome tool at this very moment. So I'm going to replace I3 with how many I4s it is, which is going to be 2 I4s. And then that's plus 12. And then I've got minus. And then I got I1, which is in fact 4 I4s. So 4 I4s times 5, right? And so that's going to give me 0. Actually, let's move the 12 over. So negative 12 equals negative 4 I4s minus 20 I4s. And I'm going to get that negative 24 I4s is equal to negative 12. And therefore, I4 is in fact equal to 0.5 amps. Once I have that, I have all of the currents, right? Because I have I4. We now know just by looking up here that I5, which is equal to I4, has got to be 0.5 amps. I know that I2 is 2 I4s, so that's 1 amp. I know I got one. I better find I1 so I keep this some sort of order. So I've got a blue one over there. Oh, I screwed that up and did two things at the same time. I do apologize. But I've got I1, and I1's equal to 4 I4s, which means 2 amps. And then I3. It should be a different color. I don't know why I lost a color somewhere in the middle here. Probably not a great thing. But I3 is therefore equal to 2 I4s, so that's also 1 amp. And then I start looking around my circuit to make sure that I haven't made a super stupid, silly error. So I look at it and go, well, I've got 2 amps coming through here. 2 amps. When I2 and I3, I2 is 1 amp, I3 is 1 amp. So these are both 1 amp. So these are both 1 amp. So I have 1 amp over here. I got 1 amp over here, so it's split into 2 amps. And then I look at R3, I3, I4. I4 is 0.5 amps, so this is 0.5 amps. And I check down here, this is 0.5 amps, and so I discover that it makes sense. The flow all makes sense. Still haven't answered a darn question, but at least it makes sense. So now the question is, what's the power? Okay, power equals I squared R, and they wanted the whole circuit, the power of the battery. So I now know what's coming out of the battery. What's coming out of the battery is 2 amps, so that's 2 squared. But I don't know what the resistance is. Well, I can go backwards in time and go V equals IR. So for the total, and I get that my total voltage is 12, my current's 2, so my total resistance would be, it's going to be 6, right? And so since I've got 6 ohms, I can simply go power equals 2 squared times 6, which is 24 watts QED. And then the second question was potential difference between A and C. I can choose any route I want to, but if I start here and I go this way, I got the correct flow current, I gain 1.5 times 1, so 0.5 volts. But now I'm going uphill some more, so I have to go up another this is 1 amp times 2, so 0.5 times 2, so I'm going up 2. It shouldn't be that much. Hold on. 1 times 2 is 2. That's fine. That's go. Yeah, that's fine. So I get 2.5 volts is how much it goes up. Okay. Now what was confusing me as I was looking at this thing going, wait, I got 2 amps. So I lose 10 volts here, which means every route coming back to home has to lose another 2 volts. So I go this way. I got 1 amp through a 2 ohm resistor. That's 2 volts. So that gives me 12 going this way. I was like, wait a second, that doesn't work the other side, but it does. If I go this way, I got 10 volts here. I go on the back side, I got 1 volt, so that's 11 volts I've lost. This is 0.5, so I have 0.5 through there, which is another 0.5 volts. So that's, now I'm up to 11.5, another 0.5, because it's 0.5 times 1, I get to 12 volts, and then I'm back home to the battery. Got it? Okay, so that's how you do a Kirchhoff's law problem. This is prettier. You're going to a little more guess and check. But in some circuits, like the ones below, you can take shortcuts if you just simply do the part you care about. You know what I mean? And so we'll deal with that when you get there. So try the problems below. I'll have a video waiting for you for when you do those problems and show you how to do those problems well. Okay? Until then, bye.